Welcome back to part 4 of Area of Polygons. Today we're going to be looking at how to find the area of a shaded region. So you might be wondering, what exactly does that mean? I'm going to let the diagrams talk for themselves. We're going to start with example 1. Now this math is not that difficult. However, it takes a while to get good at these for some people because it's all about seeing what is given to you and finding out what you could do with those numbers and the shapes that they provide you with. So if you're not getting it right away, no problem. Relook at these videos, especially this one, and follow along as you're doing the homework, all right? I know all of you can do it, so let's actually start with example 1. So for example 1, we have a very plain looking rectangle here that measures 10.5 centimeters for my height and 26.2 centimeters for my base. So first and foremost, we're going to calculate the area of this rectangle. So always start with your equation and then plug in your numbers and then simply calculate, and you get an area of 275.1 centimeters squared as an area. Now, what happens if I cut out a small piece in this rectangle like so? Well, now my area is no longer 275.1 centimeters squared. It's a little bit smaller than that, right? Because this, we're not considering that part of the rectangle anymore. That's like been cut out. Right? It doesn't have anything in here. So if I want to figure out what the actual area of the gray part is, we can do that. Not right away because I don't have any numbers here, but we can do that. So let's put some numbers to this rectangle, like so, and actually calculate the area of this window, if you will, and then you'll see what we do next. So let's calculate the area of the cutout. And while we're at it, let's rename the first equation that we use. Let's identify it, right? That was the area of the full rectangle. So let's go back to the area of the cutout. We're going to write our equation. We're going to plug in our numbers and we're going to calculate, and we get an area of 82.14 centimeters squared. So now I know that this part is a certain area, and all I have to do, like I cut it out here, all I have to do is remove it from the total area. So that's going to be our third step, area of the shaded region. I'm going to use this fancy looking equation. It's actually not that difficult to read. So this SR stands for shaded region. So just so my reader can understand what I'm calculating. And then area with the small r over here in the bottom corner is for rectangle. So it's this part here, that's why it's red. And then the small c here is for area of cutout, and that's why it's kind of a lilac color here. So let's plug in our numbers. Let's do our calculation, and we get an area for the shaded region, our gray part, equal to 192.96 centimeters squared. So again, I just want to say that the reason why we subtract this is because we cut it out, right? Cutting it out is the equivalent of subtracting. So let's move on to example 2, where we get slightly more difficult with our shapes. So for example 2 here, we have a rectangle, but part of that rectangle, the majority of that rectangle, well, at least it looks like the majority, is covered by this white triangle, right? We have no idea the size. We don't know if it's an equal, well, it's not an equilateral. We might think it is a right angle triangle, but we don't know that for sure. There's not enough details for us to know. But luckily for us, all these numbers is all we need to know to find the area of this blue triangle and this other blue triangle. Okay, so let's work with that. So let's start with the area of the whole thing, right? This whole box, this rectangle, base times height, plug in our numbers, and we get an area of 13.52 kilometers squared. Now, let's pretend this white part is our cutout. This is the part we actually cut out of our rectangle. So let's find that, that's that area. So again, start with your equation, show that equation, plug in your numbers, and then calculate to give you 6.76 kilometers squared. So we know this has an area of 6.76 kilometers squared. What we're going to do, since this is being cut out, we're going to subtract it from our total over here, like so, like we did before. So area of shaded region, or the blue region in this case, right? So same thing over here. The only thing I changed here is the area of T, which is triangle. Okay, so we're going to plug in our numbers, and we find out that our area of our blue shaded region is equal to 6.76 kilometers squared. Now you'll notice that essentially the shaded region is equivalent to the area of the white triangle. So these two blue triangles can be put together to make this white one. All right, so these are going to be your general steps. You're always going to start with the area of your larger shape, usually a rectangle. Next year you'll be looking at circles. Okay, but you always start with the larger shape, and then you move on to the smaller shape and then cut it out. So that's going to be for 95 to 99% of your problems. However, there are some more difficult problems that you need to think more outside the box. So that's exactly what we're going to look at with example 3. All right, so example 3 looks like there's a lot thrown at us, but let's break everything down one at a time. So first of all, we have a white rectangle over here that has a height of 21 decimeters and a base of 22 decimeters. And inside we have this blue triangle, the part that we're actually interested in knowing. This is our shaded region. So you might notice, one, this is kind of the reverse of what we saw of example 1 and 2, where the shaded region was the bigger part, right? This is kind of like the reverse of the cutout. We have the actual shaded part being kind of the cutout of the bigger shape outside of it, right? Now, you'll notice also about this triangle, and it's very, very important, that each point of the triangle is hitting an edge of the rectangle, all right? So even though we know this is 19 decimeters from this point here to this edge here, we also can use some quick mental maths to figure out what the length of this little piece is. Same thing on this part here. We know that this point of this triangle down to this edge of the rectangle is 17 decimeters, and we could do some quick maths to figure out what the length is here. But first, let's start with our first step, calculating the area of the rectangle. So we always start with our larger shape. So again, we put in our equation, we plug in our numbers, and we get an area of 462 decimeters squared. Now, what I'm going to have to do to find the area of this blue triangle, we're going to have to take the entire rectangle, which we have the area of, and we're going to have to cut each little piece up individually. So this piece here, cut it out of this total. This piece here, cut it out also, and this piece here, cut it out as well. So what I've done is I've broken it down into triangles 1, triangles 2, and triangle 3. So let's start with triangle 1. Let's do our calculation. Let's see what that area is. So base times height divided by 2, always write your equation, plug in your numbers, and we know that this white triangle section here has an area of 199.5 decimeters squared. Now we're going to do the same thing with triangle 2, and I'm going to explain the numbers that I use. So simply put, equation, it's still a triangle, we're still using the same equation. Now you'll notice 17, okay, that makes sense. The 17 is here, and that's my height, right, of this triangle. But where is this 3 coming from? I do not see a 3 on this diagram. Well, this is where you have to be a little bit perceptive. You have to look around and kind of use your detective skills to get that piece. So I'll highlight it here so that you know how to do it in your actual homework. So if I know the length here is 22 decimeters, well, if this part is 19, and it is a rectangle, so this side here should be equal to this side in terms of length, well then the missing piece here has to be 3 decimeters because 19 plus 3 gives me 22. All right, that's the missing piece, and that's where I got the 3. So let's actually do the calculation. We get 25.5 decimeters squared. And we're going to do the same thing with triangle 3 now. So again, equation, plug in your numbers, and again, the reason, the way I got 4 decimeters for my base is, well, 22, pretty obvious for my height, right? If I was looking at it sideways here. So that's very obvious, that's my height. But again, I know this is 4 simply because this side is 21 and this side, this portion is 17. So this missing piece with this piece has to make 21. So we know it's 4 decimeters. So we plug that in, we do our calculation, and we figure out that the area of triangle 3 is 44 decimeters squared. Now, this is where we finish this question off, and you're going to see that it looks very similar to what I've had before for the equation to find the area of the shaded region, but simply modified. All right, so this part exactly the same. Now the difference is that since I have 3 parts that I'm subtracting, I have to put it in brackets over here and add them up, right? Because these 3 parts added up are going to be altogether subtracted from the total. So let's plug in our numbers. These are all the numbers that we calculated before from step 1 to 4. And right, we do our brackets first. Don't forget BEDMAS. And then we get an area of shaded region that's equal to 193 decimeters squared. So if you need to pause this video, kind of let it sink in, or want to rewatch this section because you understood example 1, you understood example 2, but example 3 kind of lost you at a certain point. That's okay. This problem is probably in your top tier in terms of difficulty. You're not going to see a ton of these types of problems, and if you can master this one, if you know exactly what you could do, like just by looking at it after a minute, thinking about it, and like the light bulb goes off, you're doing excellent. All right, so some of these problems, basic 3-step thing, big, finding the area of the big shape, finding the area of the cutout, usually the smaller shape, and then 3rd step, subtracting, and now I'll give you your answer. But with these types of questions, you might have to think outside of the box a little bit more. Okay, so I'll be waiting on the Zoom call. If you have any questions, feel free to ask. We'll be doing some practice problems together. And yeah, that's about it. That's it for me today, guys. Bye.